let's use the quadratic formula again to solve this quadratic equation. First, we want the equation in standard form, which this equation is in standard form. Squared term, first power term, constant equals 0. Then we want to identify our A, B, and C coefficients. Well, again, when no coefficient is written, the understood coefficient is 1. So the A coefficient here is 1, the B coefficient is -2, the C coefficient is 9. So when I solve, I'll have x equals the opposite of B, that would be the opposite of -2, which is +2, plus or minus the square root of the square of b squared. Well, the square of -2 is +4, minus 4 times the A coefficient, which is 1, times the C coefficient, which is 9. All of that divided by 2 times the A coefficient. So x equals 2 plus or minus the square root of 4 minus 36. All of that divided by 2. So x equals 2 plus or minus the square root of, 4 minus 36 is -32. 4 minus 36 is -32. Can I take the square root of a negative number? And let's try. 32, make it negative. Take the square root. That gives me some sort of error message. I can't take the square root of a negative number. Well, then what are we going to do here? Well, I can't take the square root of a negative number when I'm in what's called the real number system. And because there are actual problems in applied areas, especially applied areas of math, in the areas of physics, dealing with modern physics in the study of the atom, or dealing with electricity and the flow of electricity through circuits, where you have to do problems where you have to take the square root of a negative, mathematicians invented a number system. It's called the imaginary number system. And when you put the real number system together with the imaginary number system, you create the overall number system, and that's called the complex number system. So this is an imaginary number. And together with this real number, our solutions to this particular quadratic equation are what we call complex number solutions. So it is possible to take the square root of a negative when we're working with complex numbers. So we have to learn how to handle this square root of a negative. And here's what mathematicians did. Mathematicians decided, all right, if we're going to deal with the square root of a negative in this new number system, we don't really want to carry around that negative sign with us. So what they decided to do is they decided to pull apart an expression like this into the positive number and the square root of -1. 32 times -1 is -32, isn't it? And they said, let's choose the lowercase I, the letter lowercase I, to always represent the square root of -1. So that the square root of -32 would be written as the square root of 32 times I, where I is the placeholder for the square root of -1. But then we can simplify the square root of 32, can't we? Isn't 16 times 2 32? And the square root of 16 is 4. Notice that the I is not under the radical sign. The I is replacing the square root of -1. It's outside of the radical sign. So the square root of -32, I can simplify to 4 times the square root of 2 times I. So my solutions, my complex number solutions to this quadratic equation then look like this. I replace the square root of negative 32 with 4 times the square root of 2 times I. And now separate this into the two separate fractions. 2 over 2 plus or minus 4 times the square root of 2 over 2 times I. And then do what simplifying we can do. Well, 2 over 2 is 1, isn't it? And 2 goes into 4 2 times. So our two complex number solutions. This is the real number part of the solution. This is the imaginary number part of the solution. And together, it makes a complex number solution. My two complex number solutions to that quadratic equation are 1 plus 2 times the square root of 2i and 1 minus 2 times the square root of 2i. So here I again use the quadratic formula to solve that equation, and what was new is that our solutions threw us into the system of numbers known as the complex number system because of the imaginary number we had to create in order to handle that square root of a negative.